sketch the graph of r squared equals sine theta. So what we have here, and given sort of the polar system here, we have a relationship between our angle theta and r, the distance, the signed distance, depending on the direction given by theta, from the pole here. And if we look, they're given sort of a helpful little hint. This outer ring here is meant to be 1. So I guess this would be a half. This would be 3/4. This would be 1/4. So that'll just help us as we try and gauge distance or judge things there. Okay, so we'll remove those, and we'll come back here and we'll actually give a nice plot. But I'm going to do some rough work and understand what's going on with r squared equals sine theta. Okay, so r squared equals sine theta. All right, so when I take a look at something like this, probably the first thing I want to do is slowly build up my understanding of this function. So the r squared bit, I'm going to leave that for a moment. I'm just going to look at sine theta and understand what's going on with it. And maybe plot some nice important values. So sine theta repeats every 2 pi, so I should expect this thing to loop back on itself and repeat every 2 pi. We'll put sort of pi here. 3 pi by 2, pi by 2. You can get other values, if you want to put pi by 6 or pi by 4 or pi by 3 in here. It depends on how big you want to make this. It might get a little messy. Actually, you know what? Let's go for broke. Let's give myself a little bit more space. I probably won't add in like all 16 angles that have by 6 or by 4, with those denominators. But I want to give myself a little bit more space, and maybe we'll try and understand that first quadrant just a little bit better. So we'll put 2 pi out here, pi in the middle, 3 pi by 2, pi by 2. Just gives me a little more space here. So pi by 4 in the middle there, and then pi by 3, pi by 6. Even that's kind of cramped. And if I want to, I can keep going here for 3 pi by 4. But I think we'll leave that for a moment. Okay, so we're just sort of plotting with theta normally. We're not trying to jump straight to wrapping around the pole or anything like that. And okay, what's going on? And I'm also the axis here is not r yet. We'll get there, but maybe we'll say it's r squared. Okay, but what happens with sine? So sine starts at 0, and it hits 1 up here at pi by 2. So it sort of grows. At pi by 3, at pi by 6, it's 1/2. So we'll put it here. Pi by 3, it's sort of √3/2. So it grows kind of like this. And then sine comes crashing back down at pi. And then it flips to the lower side. Okay. So there's my sine theta curve. And we want sine theta to be r squared. Now, the first thing that I noticed that is causing a little bit of a problem is, well, down here, my sine values are negative. R squared can't be negative. R is a real number. It's the distance, the signed distance to the pole. So between pi and 2 pi, not at those values because that's where we've got 0, but between pi and 2 pi, there will not be any curve. There is no point... blah, 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 3 pi by 2 that is on this curve. Because you'd have blah, blah, blah squared would be sine 3 pi by 2, which would be -1, and there's no number that you can put in that's squared that gives you -1. So we can actually write off this whole section here. You can't put in anything that's strictly between pi and 2 pi. That's not in the domain of potential thetas. Okay? So we now can focus only on 0 to pi. And we can come back here and maybe revise our understanding of sine a little bit better. Okay. So I'm going to draw 2 graphs so we can compare. So going up to just pi now because we don't need to go from pi to 2 pi. And as I said, everything repeats every 2 pi. So really we just need to look from 0 to pi. So what are my 2 graphs? So this one's going to be the r squared stuff. 1, actually we don't need to go down to -1, 1/2 and stuff like that. And we know that curve sort of, we can do it better. Right? up here sort of at 1, at pi by 2. And what we're going to do down here is I'm going to draw both r as well as minus r, because that's the thing. There are two different values that you can have that when squared will give you 1/2. Right? So we've got r values can go at most 1, and then the minus r, the negative versions, can go down to at most -1, because that would be your square up here at 1, right above the pi by 2. Okay. And okay, so what can we do? So pi by 2, you'll be at 1, or you'll be down at -1. What we're going to have is two different graphs. I'll have maybe red and or maybe green and orange or something like that. Okay. Now what are some of the other points that we can zoom in on? Pi by 4, 3 pi by 4. Now at pi by 4 as well as 3 pi by 4, sine is up here at 1/√2. Right, which is about 0.7 if we really care. Well, square rooting that, if r squared is equal to 1/√2, then r is going to be plus or minus 1/4√2. Right? And square rooting a number that is between 0 and 1 makes it get a little bit bigger. So we're actually going to move up a little bit higher. And that's true for everything. 1/2, right, over here at pi by 6, will instead, you'll be plotting r is plus or minus square root of 1/2, which is 1/√2, so it moves up a little bit. And so what happens is, effectively, the curve just sort of jumps up higher, faster. Maybe I can draw this a little bit better. But sort of up higher and flattens out at the top a little bit more. And same thing with our mirror image here. It grows a little bit faster, flattens out a little bit more, and then shrinks. Okay? And these are going to give us two different sets of theta and r and minus r values, but both lead to sort of r squared being this value. My sketch is a little off, but we'll say this is 1/4√2. Okay. So now what I can do, I can come back and I can try and read along here, left to right, and plot my graph. Okay. So we'll start with the green one here. So we start at 0, and we're gonna read along until we get all the way up to pi by 2. So we start at 0, and we will end at 0. So I should expect sort of a looping shape a little bit. Okay. And then, so r squared equals sine theta. So what should we expect? We should be going all the way to pi. Sorry, we reach our peak at pi by 2. So our peak out here at pi by 2 is 1. Okay, good. And then we will grow very rapidly. So 1/2 is here, this inner ring, and we'd be there at pi by 6. And this one's here is pi by 3. We'd be there at pi by 6 if we were drawing r equals sine theta, but we're doing r squared equals sine theta, so we're actually going to be a little bit higher, at about here. Here is 1/√2. So we're gonna just grow a little bit more rapidly. That's sort of it. That's all that's happening here. Just grow a little bit rapidly, and then we sort of have a mirror image coming down on this side. And so it's not quite a circle. It's a little more flat at the top and a little more sort of steep down here. It certainly looks like a circle, but it is not. It's a little more bulgy at the sides. Okay? And we also have the other direction. So we start at 0, but then plotting at pi by 6, we have the negative root, negative 1/√2 that we would hit. And so we get sort of a mirror image. Again, this flat, bulgy little thing. That's not quite a circle. He's sort of he's a circle somebody squished. Somebody sat on him a little bit. And so we get these two pieces here, and that is my sketch of r squared equals sine theta.